Hi guys, welcome back to the channel. I hope you are doing great today. In this video we are going to see another interview assignment from a UK startup. It's a bit old, I did it back in 2020 I think, but anyway, let's see the problem. As you can see on my screen, we need to write a pipeline that takes data from the swap API and perform some transformations, some sort of map reduce. And we need to return the count of how many people are from each planet. The endpoints, these two endpoints are public endpoints, and you can also check them online and see what they return. They will give you a JSON file, and the output should look something like this, like in JSON format. You have the planet and the number of people for each planet. The solution can be run as a script or an API or whatever you like. Make sure you have all the libraries needed, etc., etc. Keep it simple, and we are getting bonus points if we use asyncio or other advanced libraries. Now I will show you my solution. Maybe you have a better approach. I'm using requests and PySpark in order to perform a group by and then convert it to JSON. And in the second solution, I'm using asyncio as well, and I will show you exactly what I'm talking about. Let me switch screens. Actually, before I move into the code, I want to show you the data. This is the public API, swap i.dev/api/planets. You can see it yourself. You perform a GET request and it returns you this JSON file here. It's a big JSON file. It has information about each planet, and at the beginning it has the count, the number of planets, 60. The next gives you the URL for the next page because it has multiple pages, and this is the tricky part in theory, right? You have to go into that page, and this gives you the second page, then the third page, the fourth page, etc., etc. And there are many planets. Underneath the result here, the result tag, you will see there is information for each planet. We have the name of the planet, rotation period, orbital period, all this climate, gravity, etc., etc. And we have residents as well inside the list. So this planet has one resident, and this is the URL for the resident. If you click on that, it will give you the information about this resident with this name and height, mass, etc., etc. And the home world would be planet 11. So if you go back here, you will see the information about planet 11, right? Our purpose here is to find the number of residents for each planet. So my approach was, if we go back, this is the first page. My approach was parse this JSON file, check if the next element has data, then go to the next page. But before you go to the next page, check the results tag, and for each planet, get the name of the planet and the residents. This list here with all the residents. So if you check, we have the name and a list of residents, and if you perform a group by here, you will get the number of residents for this planet. That was my approach. We are not using the /people API as provided in the description. I don't know why they provided this /people API, and I had to use it. I didn't use it in the interview, and they told me that my way it's correct. It's technically correct. You can get the number of residents based, if you perform a group by here. But they want to see me merge multiple data frames, but the thing is, there is no reason actually to go to the slash people API because we have the residents here. I really don't understand what they wanted here with the second API. You don't need the second API to get the number of residents. You have it here, right inside this list. Anyway, you might figure it out yourself why they want us to use this people API, the second API. For now, I will show you my approach. So I check the name for each planet, the number of the residents here. And I create two lists, one for the name of the planet and one with the residents. So this a list that will contain this planet name 10 times and here for each resident. And then I will zip these two lists and create a data frame and perform a group by and then convert it to JSON as requested in the instructions. So that's my approach. I parse the JSON file. I go, one by one to check all the planets and keep the name and the residents. That's my approach. We perform in the main function, we call the main function, and we perform a request, a GET request. We provide the URL of the API and then we convert it to JSON. So let me run this and I will show you what it brings back. And that would be the JSON that I just showed you like 1 second before. Give it some time. I'm using PySpark, so it takes some time. And this is the JSON file here with all the data, exactly as we witnessed it just a second before on the website. And the first thing I do is to create a function called populate planets, and I provide the data, this response that we are getting from the GET request. And here, inside the populate planets function, I create another function. I call another function, which is populate planet data. And I pass the data here as a variable. I check if the response is not empty, it's not none. Then for data in the results, so we go into the results key and we perform a for loop. So we say for planet in data results for each planet. Then we check the residents. So inside, remember we have a list of residents. So we say for resident, for each resident in this resident list, I have two lists, one called planets, you see it here, and one called residents. So using the planets list, I append the planet name. Here that's the outer loop. You see here, that's planet from the first loop, and we are getting the planet name. And then in the residents list, we append the resident that we have in the second loop that we are getting from the second loop. So it will append 10 times the planet name, for example, for the first planet, and 10 residents, 10 different residents. So we would have the same planet name and different residents for 10 records. And that's how I populate those two lists here. The next thing I'm doing is to check if there is a next link in the JSON. So if there is a next page, remember we have multiple pages and we have a link to the next page. I check if the next link is not none, then again perform a request with the URL of the next link, and we call the populate planet data again, the same function that we called the first time. And once we do that, then we get the next link again, and if it's none, keep doing the same thing until there is no next link, which is, I think, a pretty normal approach, right? The first time you have to call the function here to populate the first time you just populate the lists here for the first page, and then you keep checking for next links. If there is none, stop. If there is, continue, calling this function. That's so simple. So let me show you now the results we are getting. We are getting from these two lists once we have populated them. Print planets and print residents, and you will see that we have two lists now. The first list contains all the planet names, and the second list contains the residents. And we are going to zip them. Why it's not running? And we are going to zip those two lists here. You see, that's first list with all the names. You see, we have repetitive. We repeat the planet names here because this planet has 10 residents. So for each resident, we have the planet name and the resident, which is this one. So we have here in the resident list people/1, people/2, people/4/6, etc., etc. We have 10 residents. And if you use zip function, that would give you a zip object actually, but so it's going to combine those two lists together, and that would be, this planet name here would correspond to this. It will join those lists, and this planet would correspond to this resident. This planet again with the same planet would correspond to the second resident, etc., etc. So if you pass a zip object into the Spark data frame and you provide the column names, you can do that here by using struct type that you have to import. But of course, you have to create a Spark session before. Using Spark session, you import from PySpark SQL, you import Spark session. You do a Spark session.builder.app name, whatever name you want, and get or create. And then you provide that with struct type, the columns. When you want to create columns in PySpark, you use struct type, and then you open brackets and you open parentheses and then brackets, and struct field, open bracket, the column name, the type of the column, and if it's nullable or not. And we have planet name, so we provide two columns, planet name and resident. And we pass this schema, these columns here, when we create the data frame. Let me print out the data frame so you can see what we are getting from this. And that would be a PySpark data frame that would have one column, the planet names, and the second column, the residents. Now, what we give it a second. Here we are. We have planet name and resident. So this planet name has this resident, all those residents. Let me print 20. So you can see the rest of the planets. We have plenty of entries, as you can, plenty of records, because we have, I think there are 6 pages on the website. Here you have, again, this, you can see the planet name, the resident. That's the second planet with those 3 residents, right? And this is the 4th planet with 1 resident, etc., etc. You can see the logic here, right? Now, how do we count the number of residents? We perform a group by in PySpark. You can do that by using group by the df data frame dot group by the planet name, the column that we want to group by, and perform a count. And then we can also sort descending order based on count, and dot show. It will show you the results in one go. And let me do that, and you will see the group by result. Yep, it takes a bit of time. Okay. Here's the data frame, and here, and then now it's calculating the results for the group by, and you will see we have planet name and the count, which is the number of residents. For this planet, we have 11 residents. For this planet, we have 10 residents. Unknown planet, we have 5 residents. This planet, we have 3 residents, etc., etc. And the last step is to convert this into a JSON. I don't think under normal circumstances you would like this as a JSON. You would want this as a data frame usually, but whatever, if they want that as a JSON, let's do that. And here we have, let's print, and here we need to perform a group by again, a count, a sort like before, but we have to use two JSON that would convert this into JSON resilient distributed data frame, and that's why we use dot collect. It's not a data frame anymore. When you apply to JSON, it's a resilient distributed data set, RDD, and then we apply collect because RDDs do not have show function, they have collect function, and that would give you the JSON here. Maybe it's not the best format, I guess, but it does the job. And as I mentioned, usually you don't want this as a JSON, you want this as a data frame. So the previous step. This is the synchronous version. The asynchronous version is with using asyncio. So you have to import asyncio here and import AIO HTTP. This is to actually perform GET requests asynchronously, but the logic is pretty much the same. In the main function, I created this run function here that I call with the URL, the page 1. We have to create an asynchronous client session here as session, and then you type async with session.get. We perform a GET request using asyncio SSL false, otherwise it will give you an error. And then from the response, we have to await for the response. So we have to await for it to finish and provide us the response. And then we call the populate planet data. This is exactly the same function like before in async format, in async mode or whatever. That's why we have the async keyword here. And we have to await for this function to finish when we provide the data. The next link, we are getting the next link. While next link is not none, then we perform another GET request using asyncio, async with session.get next link. As response, we are waiting for the response to come, and we call the same function, populate planet data, and we are getting the next link, and we keep doing that until the next link is none, right? And then again, with the same logic, we create a zip object with those two lists and create a data frame. We provide the columns here using struct type, struct field, etc., etc. and group by, again, exactly the same thing in the async format. And that's it pretty much. This is how you solve this problem. Maybe you have a better approach. That was my approach. Maybe you find a way to use the second API, because I don't think it's useful to use the second API. What's the point? But maybe you find another way. I will upload the instructions and the code to GitHub. Have a look. If you are preparing for an interview, you might find it useful. If you like the video, click the like button and subscribe to the channel. Thank you.